Hi, this is lesson 7.3, and in this lesson we are going to prove that triangles are similar using the AA postulate, SAS, and SSS theorems, and find measurements using proportions. So the first one we're going to talk about is the AA similarity postulate, and that says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So this is a shortcut way to prove that two triangles are similar. So like in the example here, angle K is congruent to angle Y, and angle J is congruent to angle X. So from that, we can say that the triangles are similar. So let's do some examples using that. It says determine whether the triangles are similar. If they are, write a similarity statement, explain your reasons. Well, the first thing we want to do here is find the missing angles. So we have, first of all, angle D and angle G are congruent because they're both right angles. So I'll write that down. Angle D is congruent to angle G, and that's because all right angles are congruent. So there's one reason there I can write down. Now, let me pull up my calculator here. Let's find the measure of angle K. We know two of the angles, so we'll add those together. 64 plus 90 is oopsie, my calculator didn't work. That is 154, and if you subtract that from 180, you get 26. Well, look here. This angle's 26, and this angle's 26. So we can say that angle C is congruent to angle K, and that's because the measure of angle C equals the measure of angle K, which equal 26, all right? And so now we have proven that two sets of angles are congruent, so we can say that triangle CDE is similar to triangle KJH because of the AA similarity postulate. And you can just write AA sim like that. And now you also could have found angle E, which is 64, and said that angle E and H are congruent. You could have used that one instead. You just need to give two sets of angles. Okay, let's do another one. Show that the two triangles are similar. Well, we have two overlapping triangles. So ABE is this one. And whenever we have overlapping triangles, I like to draw them separately. Okay, so we know that this angle is 52. And both triangles, the small one and the large one, share angle A. So we know that that is congruent to itself. And then this is angle C and angle D, so I just separated them. So we are given basically that angle B is congruent to angle C. And you know what? I'm just looking at that. I wrote that wrong. This is angle B, but when we look at it in the picture, there's a bunch of angles at angle B, so we actually need to use three letters there. So we would call that angle ABE. So A to B to E is talking about this right here, which is the B right over here. So that is congruent to angle C. Now angle C just has, we can use one letter there because there's only one angle going on right here. All right, so there's one set of angles. Now, like we said before, angle A is congruent to angle A, and that's because of the reflexive. So there, we have shown two sets of angles are congruent, so we can say that triangle ABE is similar to triangle ACD, and that's because of the AA similarity postulate. So there's one example. Now this next one, we're trying to prove that triangle SVR is similar to triangle UVT. So we just have to find two sets of angles that are congruent. Well, hopefully you recognize right away that these angles are vertical angles. So that would be angle SVR. SVR is congruent to angle UVT. And that is because they are vertical angles. And then we have these little symbols right here. That means that the lines are parallel. So I like to extend them just to kind of see a little better. And it doesn't matter which other line transversal you want to look at. We can look at this one. And if this is the case, angle T would be congruent to angle R because those are alternate interior angles. So, and that's because alternate interior angles are congruent. You also could have used S and U because those are also alternate interior, but we already have two now. So now we can say that the triangles SVR is similar to triangle UVT by the AA similarity postulate. All right, in the next one, it says show the triangles that they're similar. Well, actually, if we look at angle F, are there any angles in the other triangle that are congruent to F? Well, the answer would be no, because this and this don't have the same number of marks. So these all just have one mark, so they're congruent to each other, but they're not congruent to anything in the other. So we would write not similar. And then in this next one, let's see. First of all, let's look at this triangle CDF, and let's find the missing angle. So 90 minus 32, this is 58, okay? And then this would be 90 right here. So actually we have two that are 90 and then two angles that are 58. So we can say that the measure of angle, so angle CFD is congruent to the, I don't want to say measure, I want to say angle CFD is congruent to angle DFE, all right, because those are right angles. And then the 58-degree angle right here would be angle CDF. So from C to D to F, that is congruent to angle DEF. And that is because they both equal 58. So now we can say that triangle CDF is similar to triangle DEF because of the AA similarity postulate. All right, so I showed two angles are congruent, so I'm good to go. All right, the next theorem that we have is the side-side-side similarity theorem. And that says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So basically this says if AB is to RS, so if we look at that ratio, it's equal to BC to CT. So BC to ST, and then CA over TR, that's equal to CA, so this one over TR. So basically we're saying that the ratios are equal. So if we look at the ratios, they will all be the same. So it says in this example, is either triangle DEF or triangle GHJ similar to triangle ABC? So we're going to start by looking at this triangle and this one to see if the sides if the corresponding sides have the same ratio. And when I have a problem like this where I have all the sides and I have to compare them, I like to label the small, the medium, and the large in each triangle because that's what you're looking at. The small side here is 8. That's the shortest side. The medium length is 12, and the longest length is 16. And in this triangle, the small side is 6, the medium is 9, and the longest is 12. And so we want to look at the ratios of the short side to the short side, or the smallest length to the smallest length. So it's 8 in the first one and 6 in the second. So 8 to 6. And that reduces to 4 to 3 if you reduce your fraction. So now let's compare the medium sides. So the medium length in the first one is 12. The medium in the next one is 9. Well, 3 goes into both of those. 4 times there, 3 times there. So that is also 4 to 3. And then the long length compared to the long length is 16 in the first one, 12 in the second. which that is 4 to 3 also. So all three sets of sides have the same ratio, which means they are proportional. So you can say that triangle ABC is similar to triangle DEF because of the side, side, side similarity theorem. So SSS sim is what I write. But that's how I just proved it. I just showed the ratio of the short to short, medium to medium, long to long. It's all the same. Now let's say we want to compare the first one, so this one, to the third one. So then we have to look again at the short side and the short side. So this is the short, this is the medium, this is the long. So short to short. So in the first triangle over here, it's 8. In the third triangle, it's 8. 8 to 8, which is 1 over 1, or 1. Now let's compare the medium to the medium. So in the first triangle, the medium is 12, and the medium here is 10, which is 6 to 5. And these are not the same. They're not equal. So these two triangles, the first and the third, are not similar. All right, the last theorem we have is called the side angle side similarity theorem, and that says if an angle of one triangle is congruent to an angle of a second, and the lengths of the sides including these angles are proportional, then the triangles are similar. So like in this picture, you have angle X congruent to angle M, okay? And then it says if ZX, so this side compared to this side, so left side to left side, equals this side, the ratio of this side to this side, then we can use SAS, similarity, and the triangles are similar. So let's do an example like that. So we want to know if these triangles are similar. Well, again, we have overlapping triangles. All right, so let me just separate them. So angle K, and then this is angle L, and this is angle P. And the length of KL is 8, and the length of KP is 12. And K is the same in both, so I'm just going to mark that. The larger triangle, so K is right here, and then this full length is, this goes to M, and the full length, pay attention to this, is 8 plus 2, which is 10. And then from K to N is 12 plus 3, which is 15. So to show that they're similar, we will say angle K is congruent to angle K, and that's because of the reflexive property. It's the same angle. And now we're going to compare. The short side to the short side, or the top to the top, is 8 to 10, which reduces to 4/5. And then the longer to the longer, or the bottom to the bottom, is 12 to 15. Let's see, 3 goes into there 4 times, 3 goes into there 5 times, and that is 4/5. So the sides that we have here, the sides are proportional, and the angle between them is congruent. So we can use side, angle, side. SAS, similarity. And the similarity statement, I should have written that first, is that triangle KLP is similar to triangle KMN. And the reason is SAS, similarity. So when you do a problem like this, then to prove it, you would write down this information right here. And that's it for this lesson. So take a look at the worksheet and work on lesson or worksheet 7.3. Thanks for watching.